Ever wondered how one man could change the way we understand the universe? This man was none other than Albert Einstein, a name synonymous with genius. Today we embark on a fascinating journey, meandering through the life and achievements of this extraordinary individual. From his early years, through his miraculous breakthroughs to his enduring legacy, we'll delve into the mind of the man whose theories continue to shape our understanding of reality. So buckle up as we travel through time, exploring the life of a genius. Our story begins in Ulm, Germany, in the year 1879. A baby boy is born to a humble family, the Einsteins. His name, Albert Einstein. His father, Hermann, is a salesman and engineer, while his mother, Pauline, is a homemaker. Albert's early years are relatively quiet. He's not the sort of child that stands out in a crowd. In fact, he doesn't even begin to talk until he's around 3 years old, much later than most children. But once he starts, he doesn't stop, often practicing sentences in his mind before speaking them out loud. When he's 5, his father shows him a compass. The needle's invisible, unexplainable movement ignites a spark within young Albert. A fascination with the mysteries of the universe takes root, one that will steer the course of his life. Einstein's formal education, however, isn't all smooth sailing. He clashes with the strict rote learning style of his schools. He yearns for creative freedom, the space to explore and understand the world in his own way. Despite these challenges, his passion for physics and mathematics remains undeterred. His family's financial struggles lead them to relocate to Italy, leaving 16-year-old Albert behind in Munich to continue his education. But the rigid educational system proves too much. He drops out, joining his family in Italy, and unbeknownst to him, taking the first steps towards a path that will change the course of science. Little did he know his curiosity would soon lead to groundbreaking discoveries. Fast forward to 1905, a year that would forever be known as Einstein's Annus Mirabilis. A year of miracles indeed, as a 26-year-old Einstein, working in a Swiss patent office, somehow found time to pen 4 revolutionary papers that would shake the scientific world to its core. The first, on a heuristic viewpoint concerning the production and transformation of light, proposed the existence of light quanta, or particles of light, a concept that laid the groundwork for quantum physics and won Einstein his Nobel Prize 16 years later. As if that wasn't enough, Einstein then shocked the world with his paper on the motion of small particles suspended in a stationary liquid, as required by the molecular kinetic theory of heat, where he explained the phenomenon known as Brownian motion. This provided the first definitive proof of the existence of atoms, which until then was only a theory. Next came on the electrodynamics of moving bodies, where Einstein introduced the world to the theory of special relativity. It was here that Einstein proposed that the laws of physics are the same for all non-accelerating observers, and that the speed of light is the same no matter the speed at which an observer travels. This groundbreaking theory altered our understanding of space and time. Finally, Einstein penned a short addendum to his special relativity paper, introducing the world to the most famous equation in physics, E equals mach squared. This equation suggested that energy and mass are interchangeable, a revolutionary idea that would later be used to explain nuclear reactions and the enormous energy released in nuclear explosions. In just 1 year, Einstein had redefined our understanding of the physical world. He had taken us from a universe of fixed absolutes to one of shifting frames and relative perspectives. His theories would be tested, debated, and ultimately accepted as fundamental truths of our universe. And thus, a new era in physics was born. Einstein wasn't done yet. Next, he set his sights on gravity. Gravity! A force we've all experienced but perhaps haven't thought much about. The apple falling from the tree, the downward pull that keeps us grounded, it was all explained by Sir Isaac Newton's law of universal gravitation. But in the early 20th century, a patent clerk in Switzerland had a different idea. Albert Einstein, our protagonist, proposed a radical new understanding of gravity. His theory of general relativity, published in 1915, redefined gravity not as a force, but as a curvature in the fabric of space and time. Imagine a stretched out sheet and a heavy ball placed in the middle, causing the sheet to dip. That's Einstein's view of gravity, with the sheet representing space-time and the ball, a massive object like a planet. Now, objects moving in this curved space-time follow paths shaped by this curvature. So, a smaller object like an apple or a moon moves along these curved paths, giving us what we perceive as gravity. And the more massive the object, the greater the curvature, the stronger the gravity, a concept more akin to a cosmic ballet than the straightforward tug we'd imagined before. But Einstein didn't stop there. His theory also predicted that light would be affected by gravity. This was a bold claim to make because, according to Newton, light, having no mass, shouldn't be affected by gravity at all. Yet in 1919, during a solar eclipse, British astronomer Arthur Eddington observed that light from distant stars did indeed bend when it passed near the sun, exactly as Einstein had predicted. This was the first of many confirmations of Einstein's theory, and it catapulted him to international fame. His revolutionary view of gravity has since been confirmed time and again, shaping our understanding of the universe and leading to predictions of black holes and gravitational waves, which have since been observed. Einstein had once again turned the scientific world upside down. In 1921, the world recognized Einstein's brilliance. The Swedish Academy of Sciences awarded him the Nobel Prize in Physics, not for his revolutionary theory of relativity, but for his work on the photoelectric effect. This was a phenomenon that Einstein had explained as part of his Annus Mirabilis papers, fundamentally changing our understanding of light and setting the stage for the development of quantum mechanics. Post-Nobel, Einstein's career trajectory only soared further. He continued to delve into the mysteries of the universe, pushing the boundaries of human understanding and making significant contributions to the field of theoretical physics. In the early 30s, as the political climate in his homeland of Germany grew increasingly tumultuous, Einstein made a life-altering decision. He emigrated to the United States, accepting a position at the newly formed Institute for Advanced Study in Princeton, New Jersey. Here, he would continue his scientific pursuits, contributing to our understanding of the cosmos. But Einstein was not just a scientist ensnared in the abstract world of theories and equations. He was a man deeply concerned with the practical implications of his work, particularly in the wake of the atomic age. This period marked a significant shift in Einstein's focus from pure science towards advocating for the responsible use of scientific knowledge. Einstein's journey was far from over. His later life would prove to be just as impactful, if not more so, shaping the course of science and humanity in profound ways. Perhaps the most well-known aspect of Einstein's work is his famous equation E = mc². This equation, seemingly simple, encapsulates a concept that is both profound and revolutionary. It stands for energy equals mass times the speed of light squared. But what does this actually mean? Let's break it down. The E stands for energy, the M for mass, and c is the speed of light, a constant. Einstein's equation tells us that energy and mass are interchangeable. They are in fact different forms of the same thing. Energy can be transformed into mass, and mass into energy. To put it in simpler terms, consider a piece of coal. When it burns, it releases energy in the form of heat and light. That's the E in the equation. But in the process, the coal loses a tiny bit of its mass. That's the M. And the C2? It's a conversion factor, like changing dollars into cents. This equation changed our understanding of the universe. It paved the way for nuclear power and the atomic bomb. It's the reason why the sun shines and why stars explode. In essence, Einstein's equation showed us that mass and energy are two sides of the same cosmic coin. It revealed a new layer of interconnectedness in our universe and pushed the boundaries of what we thought was possible. This simple equation held profound implications for the universe. Einstein was more than just a scientist. He was a humanitarian who believed in the power of peace, civil rights, and the potential for a world without nuclear weapons. Einstein's genius wasn't confined to his groundbreaking theories, it extended to his understanding of the human condition. He once said, "Peace cannot be kept by force, it can only be achieved by understanding." This belief was the driving force behind his tireless advocacy for peace. During the height of the Cold War, when the world was on the brink of nuclear catastrophe, Einstein used his influence to voice his concerns. He was instrumental in the anti-nuclear weapons movement, penning open letters to world leaders, urging them to lay down their nuclear arms and seek peaceful resolution. His advocacy extended to civil rights. Einstein was a staunch supporter of racial equality, often using his platform to champion the rights of marginalized communities. He even invited African-American opera singer Marian Anderson to stay in his home when she was refused accommodation due to her race. Einstein also demonstrated his humanitarian spirit through his support for education. He believed that education was the key to a better world, and often stressed the importance of fostering creativity and curiosity in young minds. In conclusion, Einstein's genius transcended the realms of physics. It touched the very fabric of society, inspiring change and advocating for a better world. He was not just a man of science, but a man of peace, a man of rights, and a man of education. Einstein used his influence to make the world a better place. Einstein's influence didn't end with his passing. Indeed, his legacy continues to illuminate the path of scientific discovery and intellectual curiosity. His groundbreaking theories, from the special and general relativity to the photoelectric effect, have become the bedrock of modern physics, shaping our understanding of the universe in ways we could never have imagined. His genius transcended the world of science, permeating into our culture, our language, and the way we perceive reality. His iconic equation, E equals mc², has become a universal symbol of scientific brilliance. His image, that of an eccentric genius with wild hair and a playful smile, has been etched into our collective consciousness, reminding us that wisdom and humor can coexist. But perhaps the most profound aspect of Einstein's legacy lies in the minds he inspired. Future generations of scientists and thinkers have stood on the shoulders of this giant, pushing the boundaries of our knowledge even further. His life, marked by relentless curiosity and a deep love for understanding, serves as a beacon for those who dare to question, to explore, and to dream. From the laboratories of physicists to the classrooms of students, from the pages of scientific journals to the screens of science fiction movies, Einstein's spirit continues to thrive. His legacy is a testament to the power of human intellect, the beauty of scientific inquiry, and the endless possibilities of the universe. Einstein's genius continues to inspire us to this day. Einstein was a man of many words, and his quotes continue to inspire us. He once said, "Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution." This insight captures the essence of Einstein's spirit, his relentless pursuit of understanding through imaginative thinking. He also famously said, "The important thing is not to stop questioning. Curiosity has its own reason for existence." This reminds us that questioning, curiosity, and the search for answers are fundamental to progress in science and life. Einstein also gave us this gem: "Anyone who has never made a mistake has never tried anything new." This is a testament to his belief in the importance of taking risks, of daring to tread uncharted waters in the pursuit of knowledge. His words continue to resonate with us, reminding us of the power of curiosity and imagination. Our journey through Einstein's life and achievements has come to an end. We've traced the footsteps of a man who dared to question, who ventured into the unknown, and who radically altered our understanding of the universe. From his early struggles to his groundbreaking theories and his enduring legacy, Einstein's story is a testament to the power of curiosity and tenacity. Dive deeper, explore more, let Einstein's journey inspire your own thirst for knowledge. Remember, as Einstein said, the important thing is not to stop questioning. Before you go, we have one last request. If you enjoyed this journey through Einstein's life and legacy, don't forget to hit the like button, share this with your fellow knowledge seekers, and subscribe to our channel for more enlightening content. For those who can't get enough of this genius, we've got more videos and resources about Einstein's theories and ideas waiting for you. Keep exploring, keep questioning, and until next time, stay curious. Thank you for joining us on this journey. We've loved sharing Einstein's awe-inspiring story with you. Until the next journey, goodbye. Before you go, check out these other fascinating videos. They're just a click away, ready to expand your universe. Stay curious and continue the journey of learning.